there is this protein called cryptochrome. And this protein, in the presence of blue light, it splits down into two smaller molecules, two free radicals we like to call them, because each molecule receives one electron from the original cryptochrome molecule. And these two electrons are still quantum entangled, but they could either be in a single state or a triple state, which is what we don't really know. However, we do know that the state of these two electrons is affected by the direction of the magnetic field as of the Earth's magnetic field, really. So the state of these two electrons as to whether or not they become singles or triplets, the probability of that is affected by the direction of the magnetic field lines with respect to the Earth's surface. So what this means is that if the bird was over here, supposing, the end products of the reaction would be different compared to if the birds were over here. And because of that, that could make a different chain of cascade effects, which could ultimately lead to different brain signals. So I say that, and it might seem possible, but really there are quite some disadvantages to it. So yeah, this mechanism has insufficient evidence because of the fact that although cryptochrome might be reacting to this blue light and might be giving rise to these two free radicals, which may use quantum entanglement, it might very well just be a photoreceptor. It might just be used to detect the blue light. It might not even be used to detect magnetic fields. That might just be the sole function of it. Really, now let's have a look at the good points, really. So, there's these two. This theory, it does explain why birds get disoriented at particular magnetic frequencies. This is because the radical paramechanism predicts that if you were to have these two radicals, they would react a sort of Goldilocks region, really. They would react quite radically to certain magnetic frequencies. And really, if you were to subject these poor birds to a frequency of about 1.3 megahertz, you would see that they would start to fall down from the sky. But they actually did that, and I'm not quite sure why he wants to do that. But in addition, the theory is supported under normal physiological conditions. I mean, you may have heard that quantum physics, normally in laboratory conditions, you would look at quantum phenomena at really cold temperatures near absolute zero. So the fact that quantum phenomena occur at these high, messy temperatures seems quite mysterious. But what the idea is that the theory predicts that at these high temperatures, because the quantum entanglement dissipates quite readily, it initiates or reinitiates the radical paramechanism faster. And this reinitiation or initiation of the radical paramechanism more faster can cause could cause the cryptochrome to dissociate faster and just make chemical reactions occur faster. So yeah, that's really just it for this theory. But I'd like to end with this quote, really. The spiritual master. Deep down, nature is inherently peaceful, calm, and beautiful. The universe as a whole is perfect chaos on the surface. So what this means is that if you look outside, it seems warm and messy, and you just look at the classical physics of it. But maybe deep down, we are all ordered in the state of quantum physics. So, yeah, that's what If you have any questions, even towards the physics side of it, I'll try to attempt to explain, but the university equations are quite difficult for even me to understand.
Right, okay, I'll jump in with a question, though other people are going to have to ask a lot of questions here, because I do kind of know a lot of this already. Just to clarify with the cryptochrome example, every time it came to a mention of the kind of chemical cascade that would translate the quantum entanglement into some effect in the bird's brain.
Yeah.
you went a bit vague there. So has anybody actually suggested any mechanism?
That is literally it, actually. I've not even seen any research articles about this. There has been no clear depiction, the cryptochrome does this and then it does that. I mean, there have been mentions that it's associated with flavin, FAD, but I'm not really quite sure how. And no one has really given a clear outline of this. So that's really just it. The theory lacks insufficient evidence.
Yeah. So is it really that just someone has found a molecule that splits leading to
the
quantum entanglement
and
then sort of kind of hoped as a result?
Yeah, I would say so. And also, it's not really that they've hoped as well, because I mean, as I said before, these two are really strong points of the theory. Because if you look at it classically, you can't explain why birds particularly get disoriented with this magnetic frequency, or why really this point is showing that quantum physics can occur at high temperatures as well. So
the particular magnetic frequencies, I think that's the very strongest evidence for it. Because if there's no other reason why they'd be destructive.
For those who are confused about frequency, I could talk something about frequency if you like.
Yeah, we'll go on. Explain to us why try and explain to us why quantum physics would lead to disruption at a particular magnetic frequency.
See, so the idea is frequency is to do with a continually changing magnetic field. So supposing we had a bar magnet, right? And I would spin the bar magnet around, you would have the magnetic field of the bar magnet continually changing. So if I were to take like a compass and put the bar magnet close to the compass, you see that the compass points towards the north of the bar magnet. But if I kept the compass near the bar magnet and I kept spinning the bar magnet really, really fast, the change or the direction that the compass moves in is kind of negligible. It stays in the same direction because the frequency is spinning too fast for it to handle. So you can think of that as classical magnetism. So that doesn't happen here. According to quantum, or at least in quantum theory, the magnetism reacts to these certain Goldilocks regions, and so that this really here, it's just a point that it shows that this cannot be a classical phenomenon. This has to be a quantum phenomenon because it reacts to this particular magnetic frequency. So, yeah, if you understood that compass analogy, any other questions?
This may be a silly question, but you talked about the cryptochrome only breaking down when blue light hits it. Yeah. So in my mind, this whole sort of birds sort of can feel the magnetic field. It always sort of you just feel it, but that would mean that they would have to see.
Yep.
See. So basically, if you covered its eyes,
That's what I thought as well. But actually, upon further inspection, it does it anyway. So there are two reasons for that really interesting here. So the first reason, it could just be that when you close the bird's eye, it might just be freaking out because it can't even see. Okay. The second reason is that even though they close the bird's eye, or even though there's no blue light for the cryptochrome to break down, cryptochrome can still break down with the presence of other molecules. I do think that I believe that FAD was a molecule that could donate some of its energy to cryptochrome to oxidize it or break it down. So even without blue light, it could still break down in a sense. But yeah.
I mean, the crypto and cryptochrome is kind of like
mysterious.
Mystery
reason,
pigment.
I think the reason they called it mystery pigment was because it was kind of hard to find in the eye. Although it's present in many other organisms as well. It's actually present in Drosophila and also other organisms like even some certain plants. So it could even be used in geotropism. I'm not quite sure.
So I was about to say, has it been found in any? Has it have a known function in other biological systems?
I don't think they have. I mean, I know for a fact that cryptochrome is even present in our eyes, but I don't see magnetic fields anywhere. So that's already another evidence against my quantum. Oh wow, okay. Let's stop talking about that.
Okay, Francesca.
Yeah. So just to be a bit more clear, because I don't know about this, so just to be a bit more clear about how the entanglement works, because if I have an atom, let's pick for simplicity like helium with two outer electrons, and you've got one of them having spin up and one spin down to conserve that angular momentum that they have, So if you come across and add a magnetic field in there, changing magnetic field, and that flips one of the spins to up, all of a sudden you've got a state that doesn't conserve angular momentum. So how does it work?
What really happens, I don't have a marker, but is there any way I can draw on this? So what really happens is that in physics there is a principle called the Pauli exclusion principle, which states that if two electrons are in